All right, good morning to you. So today I will pick up the topic of uniform circular motion. When I teach this topic, I find a lot of students having confusions in their mind. They're not able to exactly understand some of the topics in uniform circular motion. So I thought I'll just pick up only that part which is causing confusion. Okay, and that part is this equation, okay, which is V is equal to omega r. This is creating confusion in the minds of the students. Okay, let's start it. Now, a lot of students, when they try and do questions on uniform circular motion, assume that the real way to apply this equation is this, okay, which is V is equal to omega r. It is not. The equation V is equal to omega r is basically nothing. It means nothing. Okay, we will come to the point to make it more understandable, but right now it means nothing. The real equation which a student of physics has to know is V is equal to omega r. So first thing, please remove this myth from your mind that you have to memorize this formula. Okay, I will explain you when to use this. Okay. Now, what does this formula tell you? Let's expand. This formula is basically a cross product of omega and r. Okay, so we are talking about the use of cross product in uniform circular motion, and I will come to more parts of it. So V is equal to omega r is the real equation that you need to focus on. It's a vector product, a cross product. All the rules of vector which are associated with vector product will be applicable. Okay, you know V is the linear velocity, omega is the angular velocity, and r is the position vector as measured from the axis of rotation. If you know the axis of rotation, measure the r, which is a position vector of the point which is undergoing the rotational motion or uniform circular motion. I will clarify this. Now, uh, since we are talking about direction, okay, the direction matters. In V is equal to omega r, there is no mention of the direction. So to me, this is not a great equation to understand. The real focus is on this equation. Make sense? Okay. Now, when we say this is a cross product, so it is obviously having two parts. One is omega and r. These two are vectors, right? So what is the direction of omega? That is the first thing you need to understand. Now, the direction of omega. Assume you have a disk. Now, this is your disk, okay? This is a disk you have. It is moving in, say, anti-clockwise direction. You can see this anti-clockwise direction, right? Since it is moving in anti-clockwise direction, the thumb tells you the direction of the angular velocity. Again, curl your finger in the direction of the rotation. Okay, so this is the direction of rotation here. And the thumb will tell you the direction of omega. In this case, the thumb is pointing out. Okay, what is the direction of the position vector? It is measured from the axis of rotation to the point which is undergoing the rotation. Okay, so I hope the concept of how to apply the direction sense is getting clear in your mind. Omega is actually perpendicular to the plane of rotation. So this is your plane of rotation. Omega is perpendicular to it like this. If the and remember, you have to use right hand. Please don't use left hand. Okay. The direction of vector product comes from right hand rules. Okay. Now, so I'm sure I'm able to emphasize this point that we are dealing with vector product. The second confusion which the students have is, we will use these equations for questions that have circular motion, uniform circular motion, because they see these questions in uniform circular motion. The point is that is not correct. You are not supposed to use this equation only for uniform circular motion. In fact, these equations have to be used for other scenarios also. Okay. So second confusion is being removed. You can use this equation for any rigid body rotation, just not uniform circular motion. Use it anywhere. Apply it to any rigid body rotational motion. What are the situations where you can apply these? Let's talk about it. Rigid body motion. You can use this equation. Don't think in your mind that this is only applicable to uniform circular motion. It's a vector. No. Apart from uniform circular motion, you can use it for rigid body. You can use it for rolling motion. For those who know rolling motion, the topmost point is at the double speed as the bottommost point, right? It's not a uniform circular motion. The wheel is rolling. The top point is at 2VR. The bottom point is at rest. We're talking about pure rolling here. But in a uniform circular motion, the speed is constant everywhere. Not in the case of pure rolling. But you can still apply V is equal to omega R. I mean, omega cross R, okay? In pure rolling too. Third, non-uniform rotational motion. If the word uniform carries a weight. So even if the motion is rotational, it's non-uniform, feel free to apply these equation. I mean, this equation, which is a vector product. And then, of course, if you have a curved motion, any curved motion of any complexity, please feel free to use this equation. So myth number 2, uniform circular motion, I'm going to use omega cross R. For other rotational motions, I cannot use this equation. Wrong. You can. So, right? So, two myths. V is equal to omega R. Wrong. V is equal to omega cross R. Correct. I will apply V is equal to omega cross R to uniform circular motion. No. You will apply these to the 4 given situations apart from the uniform circular motion. Yes, you can apply it to uniform circular motion too, which is the point I am coming to now. If you talk about uniform circular motion, in the case of uniform circular motion, what happens is, okay, so now I'm restricting the conversation to uniform circular motion. Before that, I told you, don't restrict the use of this equation. First, I corrected the equation, and then I said, don't restrict it to uniform circular motion, but apply it to other situations. Now, uniform circular motion, which is where a lot of students get questions in their exam paper. Let's talk about that situation too. In that situation, what happens is there is a special thing which is happening in those situations, which is that V is equal to omega cross R is still applicable. It is, but something special is going to be applicable here. The special thing which is applicable in this situation is that the omega, okay, which is your angular velocity, is always perpendicular to the position vector. The angular velocity is always perpendicular to the position vector of the body undergoing a uniform circular motion. And therefore, in those circumstances, you apply this. V is equal to omega R. How? Because if V is perpendicular to R, then the magnitude of V is equal to omega R sine of 90. So you do end up with V is equal to omega R. Yes. Use it for uniform circular motion. But remember, this is partially true because it is only the magnitude. The direction of the omega still needs to be understood. The direction of position vector still needs to be understood. And the linear velocity direction has to be found out. If you are talking, if this is not a disk motion, but is a uniform circular motion, and the angular velocity is anti-clockwise, and therefore the vector is outward, the position vector is directed upward like this. It's a uniform circular motion. The velocity will come out to be tangent to the circle. So if you do the right hand rule properly, which is screw rule, if you apply it like this from omega to r, you are actually screwing and you are moving the velocity vector inside, right? Standard way to apply right hand rule using the cross product. So you use your right hand and you will get the direction of the velocity. So this rule, V is equal to omega cross R, is helping you find the direction of the velocity. It is not just because it is known to you that it is tangential. It actually comes from the fact that you have the knowledge of V is equal to omega R. Again, the omega is this, perpendicular to the plane of revolution. Uniform circular motion, it's a point mass, it's a revolution. It's a revolution. Outward position vector is this, right? And therefore, when you do omega cross r, the velocity vector is perpendicular to both omega and r. Velocity vector is perpendicular to both omega and r, which is a standard known fact about vector product. The resultant of a vector product is perpendicular to the plane of omega and r, which is plane of rotation, and is found using the direction, right? Which is, I'm using moving from omega to r like this, and my screw is going like this, so the tangential velocity. So V is perpendicular to both omega and r. I hope this made sense to you. Now we are only talking about uniform circular motion and using our knowledge of omega cross r, which is a overarching equation. The overarching equation is being used for uniform circular motion, which is what you encounter most of the time. And therefore, this myth develops that you cannot use this equation anywhere else. You can. In order to make your life more simpler, let's do some numericals. Multiple choice. Simple ones will give you good insight and a good experience of solving these questions. You can go to my playlist, which I'm uploading, of uniform circular motion, and see a lot of numericals solved there. Maybe I think 30-40 videos may be there. You can also join my community tab, which has I think 2,000 questions now on physics. All right, let's start with the MCQs. Let's read the first MCQ. Okay, very conceptual. In a rotating disk, the angular velocity is in plus z axis. Okay. What is the direction of the linear velocity at the point on the edge of the disk in the xy plane? All right. So it says that the rotating disk, the velocity, angular velocity is in z axis. So I will draw the disk here. Okay. We will draw the disk here so this is my disk. The angular velocity is in z axis. The disk is in xy plane. Very good. So disk is in xy plane. This disk is rotating. This is the direction of omega. So likely omega is in z axis if I've taken this as z axis. So I, j, k, right? This is a disk which is maybe, the direction is not given of the rotation, doesn't matter. Question is, what is the direction of the linear velocity at the point on the edge of the disk. Choices. The direction of the linear velocity is radially outward. Linear velocity is not radially outward. The position vector is radially outward, right? It is measured from the axis. If this is the axis, this is my radially outward line. This is not the direction of linear velocity. Wrong. It is a position vector, which is the radially outward vector. Next, it is tangentially to the edge. Maybe. Okay. Question mark. It is parallel to omega. Linear velocity is parallel to omega. So he's saying the direction of velocity is this, right? It is parallel to omega. I don't think so. If you go back to the discussion, V is always perpendicular to the plane of omega and R. It is perpendicular to omega, it is perpendicular to R. Wrong. It is perpendicular to both omega and R. Of course it is. It will always be, because we're dealing with the concept of what? We are dealing with the concept of omega, the cross product. So the resultant cross product V is bound to be perpendicular to omega cross R. We know the concept of, right? So we know that these are the three vectors, and this is A and B, and I'm doing A cross B. The C is going to be perpendicular to A and B, or the plane containing A and B. So yes, right? This also makes sense. Now we have to make a choice between tangentially to the edge and perpendicular to both omega and R. I think we are not sure, okay, about tangentially to the edge, although we know, from our discussion so far. But if you look strictly into the definition of the cross product, it is always perpendicular to both omega and R, is a more emphatic scientific answer. Though I don't deny that it is radial, it is tangential to the edge in a circular motion, but this is not a uniform circular motion. This is more of a disk. Okay. So I think the closest we can get to is D. We are very certain about it, right? So we give the answer as D. Let's move to the next question. And this will really, really help you understand this. Okay. V is equal to omega cross R. If you notice, let's talk about this question now. Okay. I hope you've been able to digest it. Let's come to this. So you're given a question in which omega is equal to 4i plus 3j. And the position vector is 2j plus 5k. Nowhere in the question it is mentioned it's a uniform circular motion. Nowhere. Now, if you have to, the question is, what is the magnitude of linear velocity? A lot of students will say there is no mention of uniform circular motion. How do we solve this question? Because we only know V is equal to omega R. Can we really apply this? How do we solve this? Can we really apply this omega cross R to find the linear velocity? Yes. That's an outcome of today's discussion. You can apply. Nobody stops you. Go all out. Apply it. Let's solve this question now. Okay. Standard question. So I will draw the matrix. Okay. I'm going to write I, J, and K. This is 4, 3, 0. And this is 2J, right? So this is 0, 2, and 5. Now I'm solving the cross product using the determinant method. For those who don't know how to take a cross product, go back to my playlist on vectors. It is meant for students of physics who are trying to master some maths so that it helps them solve physics questions. All right. So let's start solving it. So I 15 minus 0 minus j 20 minus 0 plus k 8 minus 0. So I'm not spending too much time explaining you how did I get this. This is one question you can expect in the examination, in comparative examination, any public examination which has physics. How do you take a cross product using determinant method? Go to my playlist of vectors, you will be able to find it. Now, this is 15i minus 20j plus 8k meter per second. Right? It was not a uniform circular motion. Some motion governed by these two points or vectors, and you are expected to find the instantaneous velocity of the point which shows these two vectors. Which answer is the closest? I think it is 15i minus 15i minus 20j, and it is 8k, right? So the correct answer is this, minus I think the choices are not correct. The correct choice should have been this one, right? So it is plus 8k. Okay, sorry about that. I think this should be 15i minus 20j plus 8k. So the answer number 1 is the correct one. I have corrected the first choice. Seems the answers were not correct. Okay. And do the calculation. So I hope you get the point that this equation is a very powerful equation, and therefore mastering this equation is more important than just knowing a little part of this equation which pertains to uniform circular motion, which is this small equation. Don't fall into the trap of knowing only this equation. Go beyond it. One more small quiz, which is in the box. So a situation is something like this. So now what you're doing is you shift the axis of this disk to this place. Okay. So I have shifted the axis of rotation of the disk, which was passing through the center, slightly above. So maybe 2 centimeter, 1 centimeter. The question is, what is the impact on calculation of velocity? How does it impact the calculation of velocity? What changes? Okay. The real answer is the rule of V is equal to omega cross R. V is a vector. 2 does not change. You can still apply it. Changing the axis means you're changing the value of R, the position vector. And therefore, you will get a different V. That is the only difference. You change the position of the R, which means you change the R vector in itself. You will get a new velocity. So if you change the axis of rotation, the impact on velocity calculation is not there. You still need to apply V is equal to omega R. You will get a different answer, which is magnitude. But you will not, use another equation because axis has changed. Okay, just a small tricky quiz for you. So I hope you liked this lecture. If you did, subscribe to my channel, spread it in your friends, and if you have a certain topic in your mind which you want to be covered and you don't have clarity on it, do let me know. I will make a video on that depending on the priorities, importance of the topic, and keep watching my channel. It will help you in your examination and score very good marks. Thank you very much.